All right. Thank you all for having me, and welcome to this beautiful Monday morning here in Reno. I've been drinking my coffee. I hope you have too, because today we're going to talk about the right drone for drone land surveying. And I'll ask you to bear with me a little bit. This is actually the first time I've given this talk. I've been talking about drones for 7 or 8 years, and I've been talking about hardware and that sort of thing. But usually my focus is on the data processing. And so this is the first time I'm giving an entire talk dedicated to nothing but drone hardware. So as part of that, I really want your feedback. If you've got questions about specific hardware, how it works, please let me know, because my goal here is to actually let you guys know everything that I've learned from working in the drone industry and processing drone data for about 7 or 8 years at this point. So a little bit, though, to talk first about what the objectives are, what I want to cover today. Well, like I said, it's a summary of all of the different hardware learnings that we've figured out from processing 10,000 plus data sets, drone data sets for land surveying, across all kinds of different hardwares as well. So we've gotten to work with the data from way more different actual physical drones than most people have. And that means we're going to ask questions like, well, one, how should you evaluate a drone? We've talked to a lot of people that look at drones very differently, based only on cost, only on capabilities, where it's manufactured, all of this stuff. We're going to talk about all the ways that we think you ought to look at how you evaluate a drone. We're going to look up what pieces make up a drone system as well. I say drone system because oftentimes the drone is only a single part of it, right? Whether or not you even include the sensor, the camera, or the LiDAR thing as part of a drone system, or the ground equipment too. What are you using to plan your missions out? What sort of GPS unit are you using to connect it to for RTK? All of these things comprise what we would call the drone system. So we're going to talk about the individual pieces, where they can be traded out and things like that. We're going to talk about what manufacturers and drones are popular. I got a whole section walking through many of the most popular drones, talking about the benefits, the drawbacks, the pluses, the minuses, all of that, of what are the most popular drones, why they're popular, and what kind of alternatives there are out there. And then lastly, I'm going to talk about what's the best drone for me. Because part of the reason that there's a need and a desire for this presentation is because if someone says, what's the best drone? It's not this one, go buy it. It's the easy answer, everyone should have the same drone. It's not, because different businesses have different needs, have different budgets, have different project types. And so there is definitely a best drone for you that might not be the best drone for the guy sitting next to you. And that's where my goal is, to educate you guys as much as possible on making the right decision for you, for your company, of picking the right drone for you. A little bit more just about us. So Aerotos, our company, has been doing drone data processing for land surveyors for about 2014, I guess 9 years now. So the way that our company works and why we've gotten to know so much is that we process drone data for surveyors. Surveyors fly a drone, send us the data, we turn it into CAD files. And that's not a sales pitch at all, but more relevant in that we get to see so many different survey workflows, so many different drones out there. And so we have a different perspective of what actually makes survey companies successful. What drones are being used a lot because they're actually getting used, and what drones are bought because they seem like they'd be really cool and then don't actually get used because they're more challenging than you would expect. So we come at it not from a hardware sales perspective of trying to say, ooh, what's the coolest new hardware, the latest and greatest thing, but really from a data perspective of what actually gets used the most in surveying and what makes surveyors successful in a drone program. So that's my perspective, and I think that's actually really important for this, because I'm not I am a technological enthusiast. I really like tech. I really like drone stuff too, but that's not my primary goal here. It's really coming from the data and business aspect of these things. A little bit about me. I am the CEO and actually lead photogrammetrist. So I have a formal background in finance and statistics, and learned and got certified in photogrammetry as well, which is where I've been working the last 7 years or so. All right. So my goal today, what I hope that you guys can take away from this is, I want to help you build a drone program with a couple of key criteria. One, that you will actually use. Again, where I'm at in data processing, I see a lot of drone programs that people don't use. They buy the drone because maybe the boss says, I really want us to get into drones. So they buy something really cool from their dealer who's a friend of his. and then it never really gets implemented. So one of my goals is to make sure that this actually gets used and isn't just a purchase of a piece of hardware to put on your website and say you do drone services and you don't actually. I also want to get you one that saves you time. That's another kind of really important thing for me. The point of a drone program should be to save you time, get better data, and actually make everything work better in your business. It shouldn't be a time sink. It shouldn't be you get a drone and now you need to do 3 days of training and 6 hours of prep, and you need to get to the site a couple hours or days early, and then it takes months to process the data. No, a good drone program should save you time. So that's an important criteria when we evaluate drones as well. And gets you better data, right? This isn't, we're not talking about toy drones here, although actually I do have a little section about toy drones in case you're interested in just taking pictures around the house. But I'm not talking about toy drones that just take pictures of a site. We're talking about getting actual good survey quality data, getting it into CAD, getting it through that whole survey workflow. And to accomplish those goals, I have a couple of kind of guiding principles for me. And again, I think this is really important so that if you hear what I say and say, oh, this guy's an idiot, he doesn't know what he's talking about, you'll at least know why I'm saying the things that I'm saying. And that's because one of my guiding principles, there is no best drone for everyone. Like I said, different budgets, heck, different job sites. If you're doing only 5-acre boundary surveys, that's going to be a very different thing than if you are regularly doing 1,000-acre topos. If you work only in the deserts of Nevada, that's going to be very different than if you work in the woods and mountains of California. So there are absolutely different drones for different people and different businesses. Individual companies, and even individual operators. Another thing that we often see is the wide range of expertise in drone operators, ranging from people that have 20 plus years of survey experience. They know every single option on their data collection. They know every single way to process, they know everything about the drone, all the way down to an intern who was given a drone and about 30 minutes of training and sent out to a site and say, go fly this thing. So even just the operator who's going to be flying the drone will influence what type of drone you can buy. Some are stupid easy to fly, and others take an awful lot of training to be able to reliably collect good data. That really matters as well. That said, there definitely are some bad drones out there. There are some drones that just aren't good for land surveying, that are designed for other applications. There are ones that are really cool for thermal night vision for police and search and rescue applications that aren't going to work for survey, or toy drones, and some that just quite frankly are not built all that well. And there are a lot of pitfalls that we see when buying drones. And my goal is to help you avoid as many of those as possible. And lastly, and this is probably one of the more, dare I say, controversial aspects of what I'm about to tell you, is I don't like research programs. I like businesses. So I'm going to talk about a lot of the kind of cutting edge drones that are more along the sides of a research program, but that's not what I'm focused here today. Because I'll tell you in advance, I'll kind of jump to the conclusion. Of any of the drones that I recommend, there are going to be drones with more powerful lasers, more advanced features, and more potentially higher accuracies in certain circumstances. But they are so ridiculously expensive and complicated and hard to use and unreliable that they qualify, as far as I'm concerned, as a research program. So my recommendation here isn't something, hey, this is a cool technology. You might figure out how to make a return on it and use it on a work site within the next 12 months. That's not how I work. I don't like research programs. I like businesses and actually running a business off of this thing. And that's what I'm talking about today. And this slide, I actually found a photo of myself from about 10 years ago with one of the first drones that I built. Part of the reason I don't like research programs is because I kind of used to run one a little bit. In fact, that's how we got into the drone business about 10 years ago. And so that's me with one of my really hacked together, well, that's what pretty much all drones look like about 10 years ago, with a little camera on a kind of homemade gimbal. And I can tell you that thing only crashed about 1 out of every 5 times I flew it. So that was pretty good for the time. Not all, well, assembly error more often than not. Sometimes software error. But with that many hand soldered wires, you can bet that 1 or 2 of them are going to pull loose when it starts vibrating and that sort of thing. This is exactly the type of drone that I am not going to be recommending to you today. If you want to do this on your hobby time, if you want to learn how a drone actually works, all of the different hardware components to it, the skills of soldering, it's a fun hobby. If you want to build a race drone, I've built a ton of race drones. They're awesome. I love those things. They are a horrible investment, a horrible business, and not good for any sort of surveying purposes. This is an academic study. If you want to do this with one of the colleges or just on your free time, it's super fun. This is not a business, and this is not how you should be running your business. So that's kind of my whole spiel that I've crashed a lot of drones in the early days to realize that you don't crash drones on business. And quite frankly, good drones nowadays don't crash. It just doesn't. It's almost completely unheard of to crash a drone. And pilot error has become negligible too, just because, most drones nowadays, at least survey drones, flying them should be push go. That's really all you should ever do in survey drones. They should fly well above any obstacles, mission planning, they can go follow terrain up and down. The autopilot is very powerful. Their pilot error has been almost completely eliminated, unless you really do something stupid. But pilot error is pretty much gone. High quality drones, manufacturing defects are extraordinarily rare. The self-checks on the software to say, oh, there's something out of tolerance in one of the battery cells that prevents it from flying is very, very good. So drones just shouldn't crash, like basically at all. They're the most boring things in the world. And to me, that's a good thing, right? A drone ought to be a pretty boring tool that, the first couple of times you fly it, it's exciting, but the goal is to make it pretty boring. So as we move on from, the main thing, don't make a science experiment, try and make a business. At least that's my perspective on this. There are a couple of questions that you probably want to ask yourself when you are considering which drone of the other drones that are out there, which ones to buy. So one of the first questions is, what type of projects do you typically do? And the key things among this being, how big are they, how many acres are they, and how much vegetation? Because this will influence a lot of the types of things that you need. When we say how many acres, that'll lead to, well, if you do, smaller project sites, you can get away with, generally speaking, cheaper drones, lower quality cameras, smaller drones, and less robust RTK or PPK systems because they're smaller sites. You don't need to interpolate as much data. You can just set a couple ground control points. The larger sites you get, you need better drones or bigger drones sometimes, better cameras. Definitely you're going to want better RTK and PPK. And eventually on the very large side, you want to start considering getting into things like fixed wing drones or things, or other types that can actually fly, not only to fly a lot larger areas. And how much vegetation is another big question for LiDAR is the hot topics right now. I know there are plenty of LiDAR drones that exhibit all tons of people sensors. And so I've got a whole section talking about LiDAR, and I'll spend a good amount of time about LiDAR. LiDAR is the most exciting thing that is most common and most cost effective. The majority of data that's actually being processed on live projects day to day in, day out, is going to be photogrammetry projects. LiDAR still has a lot of people in that research, so a lot of people are out there using it for live projects. But photogrammetry actually remains way more popular and is way more often on more sites. Or not the whole job site, not, depending on the state, but more often than not. But how often are you flying? In general, the more successful go out to job sites or certain criteria. And if I'm do that, go to the truck, push the go button, and when you start flying it every week or two, it does what I always wanted to do, which is it becomes super boring. It becomes push the button and it flies and buzzes around. But if you're buying a drone for, well, I have one project a quarter that might be able to use a drone on, well, that'll definitely influence what you decide depending on your budget, how big the site is. Or what we found is people are generally more successful when they start with smaller drones on smaller sites used frequently and build confidence and very well versed in drones, understands it, loves drones, and they buy the drone effectively for themselves, and they can buy a more complicated, more technologically challenging setup because they know how to operate it. Other times you have kind of the boss that's buying it for his company that he's given the sign off and say, I want to buy this drone because I want to use drone services. And that's where things can get really dicey because he sometimes will buy the really complex, challenging drone and give it to a guy who's willing to learn, willing to fly it, but might not be the drone guy that a lot of other people are. And then that leads to a lot of challenges. So there's some drones that are much easier that are the type that I would recommend. Buy these for your survey crews. And other ones, buy them if you are really interested, only if you are in And then how technically advanced are the pilots? That's part of it. There are some drones you kind of got to let troubleshoot. I don't think that's necessarily a great thing for a lot of these drones, but they don't always work the first time. They repair, you need to turn them on and off. There are radio link connections with some of them, and other drones are just going to work a little bit better. So going into how we evaluate drones, one of the first things that I can point out is we don't evaluate drones. For example, if I saw a drone without a camera on it, that's a big, powerful, impressive camera. It's very cool, and it's a pretty good survey. But some of the things that we hear people when they say, I want to buy this drone because, it's, it's got the best camera I've seen. As far as I'm concerned, how many megapixels the camera has is completely irrelevant. That's not the criteria. We use what kind of data it can produce at the end. What's its resolution, what's its accuracy at the end. The megapixels of the camera, while something that every hardware manufacturer will put front and center on the top of their marketing pages, is only a small piece of actually getting to accuracy. Does it have an RTK and how capable flying at in different sites? What kind of shutter system does it have? All of those put together create what kind of accuracy the drone can get and how much area it can cover. Those are things that I care about. But something like just the number of megapixels on the camera is not what you should be used, and not what we use to evaluate drones, and what we don't think you should do. Likewise, how powerful the LiDAR sensor is. I can tell you, having seen lots and lots of LiDAR data sets, I've never ever had someone say, oh, gosh, this LiDAR data set would be good if only the LiDAR sensor had 800,000 pulses per second instead of 600,000 pulses per second. Darn! That's not like one of those things. And yet, when people are making purchasing decisions for a lot of these things, they say, ooh, well, this LiDAR sensor has 800,000 pulses per second. This one's only 600,000. That means it's 33% better, which is absolutely not how this works, and that's not how we evaluate. Again, what we care about is that final accuracy, that final data product, and it is not like how powerful the sensor is or how many pulses per second it is that matters. Again, there's a lower limit, there's a level that wouldn't do survey, but just the LiDAR sensor specs are not going to be getting what makes a good drone or a bad drone. Another interesting one, how many minutes of flight time the drone has, also plastered all over a lot of the marketing materials for basically all drones. All manufacturers do that. And I always say, they would say like, oh, how many minutes does it have? And it's like, well, how many minutes is your job site? And that's kind of what we care more about. It's how many acres can it cover? How much land area can it actually cover with the necessary overlap? And that's where things like battery life combine with things like camera quality and RTK quality and focal length of the drone and all of that. But minutes of flight, that's not really a key thing. How cool the drone looks. A lot of people buy that too. And I guess this might even be, there's some reason to do that if you're buying it for marketing, staying on top of the competition. You can put a picture of your shiny new drone on your website. But how cool a drone looks is not typically our evaluation criteria. In fact, there was an era about 5 or 6 years ago when DJI first released some of the Phantom series. They had two different drones. They had the DJI Phantom, which was white, and the DJI Phantom Obsidian series, which was exactly the same drone, but in black. So many people said, ooh, I'm going to buy the black one. It looks cool. It looks all military spec. And then what they realized is that if you flew it in the summer, it was way more likely to overheat and have battery shutdowns because it was way too hot because it's a black drone in the middle of the summer in Las Vegas or something. And I'm sitting there like, oh, why did people buy the black drones? They look and now all of a sudden they have to buy another drone. So we don't evaluate it based on how cool the drone looks. Again, we're very data forward on this. Likewise, if it can be used in a racing league, that's another thing. Top speed of these drones, don't really care about that. I've said before, I have race drones. I've flown them. They are fun. They are cool. But that is not what makes a good drone. And that also ties into things like whether or not it has a thermal camera. We see people saying it's like, oh, well, yeah, I'm buying it for survey, but I might want to use it for like thermal inspections down the line. I might want to eventually get into NDVI agricultural analysis. We found that to be a pretty bad, or not bad, but I understand the approach. I very much understand the desire to try and take this investment and apply it to other applications, but we found it to be pretty unsuccessful because when people try and buy these drones that are, oh, it's modular, I can upgrade it in 5 years, these drones realistically, they're not going to last 5 years, or well, they may last 4 or 5 years on the upper end. They're not going to keep making new cameras for it in 5 years. They make new drones. It's like a cell phone, right? Cell phones are great these days, but if your phone is over 5 years old, it's definitely on the longer end of things. But whether or not it has a thermal camera, this is a surveyor's conference. We're survey focused. The people that we see successful at survey are not the ones that share a drone with a public safety arm of a different business unit, and then also do it for crime scene reconstruction with the local PD. They buy a drone that's a survey drone, and it lives in a survey truck, and it does survey. Those are the ones that are the most successful, not the ones that have a lot of this crazy software. Not because it isn't technically possible, but because all of those workflows, all of those kind of ugly real-world things need a heck of a lot more now. So how we do evaluate drones? Well, we evaluate things like what is the accuracy, the final accuracy that it gets of the survey. When I say accuracy, not accuracy of the camera, not accuracy of the RTK, not accuracy of the laser, not of the IMU, of the total system altogether. We measure accuracy on the ground. We measure it according to the ASPRS positional accuracy standards, and that is how we measure accuracy of an entire system. That's what we mean when we say accuracy. We measure the total cost of ownership, and total cost of ownership is not just the cost of the equipment, the cost of operating the equipment. Like I said before, there are some drones that require very well-trained and specialized people that are costly to operate, that you have to count in the cost of labor there. The cost of data processing. Some drones create way, way, way more data than others for similar project sites, and that increases the cost of data processing. So the total cost of ownership is actually really important on the ROI of your drone. Things like skill required to operate is important. Ease of use is actually important. Again, easily overlooked compared to a drone where you can just bring it out of a truck, it's dusty, it's been bonked around, put it on the ground and push go and it flies. That makes a drone program way more successful and reliable. But also things like hardware and software support and company longevity. That's becoming a more interesting one and more valuable, especially to me, having seen all corpses of drone manufacturers over the last 8 years. Building drones that are really cool concept, just don't quite work out. This one is an interesting example that got a lot of hype at the time. They had some cool marketing. I think it's called the Firefly 6 or something like that. Small bespoke drone manufacturer, used to exhibit at some of these survey conferences. And the whole idea is it's this plane style drone that can take off vertically and the propellers that there for an hour and do 1,000 survey. A bunch of surveyors thought, hey, that's a really cool idea. I like it. And the company went bankrupt because the drones actually weren't all that great. There were a lot of technological issues. There were a lot of issues with the camera interfacing with the RTK system so that the timing and accuracy on the photos was not great. And the company went under, and they're saddled with these things a lot of times. And they're effectively unflyable because there's no longer any software support. You can't get new parts or upgrade them. And it's a real bummer because it was, it's a cool idea. I like the idea, but the execution just wasn't there. So I'm going to try and kind of avoid some of those things with the best of I can of which companies are actually going to be around for a little while and are worth buying from, and which ones are, potentially in, I don't want to say trouble, but you might want to reconsider just from the company longevity to make sure that you're going to spend, $20, $30, $50 more $1,000 that your drone can actually use more than word of caution, and I apologize for some of these if there are any other vendors or hardware retailers in the room today. But one, I always say beware salespeople when it comes to buying hardware. Most drone sales are sold by dealers, and most of them are commissioned. And I don't like to, guys. My company has salespeople too, but they are commissioned to push the drones that they sell. They are incentivized to sell more expensive and more complex drones, and to advertise all of the good things about their drone. But that means they're often pushing a more expensive drone than you probably need. I'm on the other side. I'm on the data processing side. I like to admit my own conflicts of interest where I can. I like drones that get used more often and that make companies successful, and those are very often the lower end drones. So I actually go opposite and push people to cheaper drones more often because I see them get used more often. Also, don't buy on tech specs alone. If that hasn't been made clear, it's part of that research program. If you buy the drone with the absolute top technical specifications, you'll hit that side out of the park, and the actual cost of operation, cost of data processing, the complexity, and likely company longevity is all going to be in a lot of trouble if you buy just on tech specs. Again, don't ignore tech specs, they matter, but don't buy on tech specs alone, because the entire workflow is what matters. It is not buying the drone, it is actually going to know who's going to fly it, who's going to charge the batteries. Is it charging the batteries? What an interesting thing that I didn't even put in this presentation that can actually trip people up a lot. There are some drones where, okay, there's a dock, stick the battery in the dock and charge it. Cool. And then there are drones that's like, oh, well, this is a 6x LiPo, so you have to first plug in the main battery, you have to plug in the balance charger, and ensure your voltage is set properly so it doesn't overcook it. And we really recommend putting it in a fireproof box in case it catches fire while charging. Oh, and never charge it overnight. And always make sure that someone's there monitoring your battery while charging. If that sounds insane to you, don't buy these research program drones, because that's what it's like when we're talking about the whole workflow. And a lot of these companies that use these bespoke systems will have a charging system like that. Now, if you know what the proper voltage on each cell of a 6S LiPo battery is, then maybe you can do that, but a lot of people don't. And I'll go back to that picture of me with my soldering iron and say, yes, I almost burned compartment down once because I overcharged the battery. But yeah, this stuff can be really complicated, all told, of all of the different factors in a drone that puts it together. So like I said, please ask questions if something doesn't make sense. If you're curious about an individual drone as I'm going through it, raise your hand and ask a question. Likewise, you probably won't become a drone expert overnight. I'm going to give you as much information as I have about the individual drones, the individual technologies, and all of that. But this goes really deep, especially, I mean, there are things that are way out of my scope too, despite working in this industry for 8 years. I can't tell you about the autopilots on a Predator drone system, as cool as those things are. And lastly, you can always talk to an expert, people like me, people like my company. You can always reach out to us to actually look for advice on what drone to buy, how we can maybe help you get set up. Because again, we're a processing company, but we help people get set up with drone hardware too, purely because it helps us process more data as well. And that's what we really, really care about, is you using your drone more often on more projects. All right, so with that, we can actually get into some of the components of a drone after more coffee. All right, to start with, let's talk about the different airframe types that are out there. Generally speaking, drones can be categorized into 3 different types of ways that they fly. There are always outliers to this and, crazy bespoke things, but starting with 3 different outliers. The first is a small all-in-one multi-rotor. This is things like the Mavic 3 Enterprise, which is kind of the DJI's latest flagship drone, but would also include any of the other Mavic series, the Phantom series of drones, a lot of the Autel drones and Evo drones and Skydios. They're usually around 1 foot in diameter. They weigh a couple of pounds. All-in cost for these style of drones for a survey drone is typically on the order of about $5,000 to $10,000. And that's going to be higher than most of your list prices. When I talk pricing here, I'm usually talking about what your actual all-in cost is once you buy all of the other accessories and batteries and cases and chargers and whatever crap that you need to put it together. You're looking at around $5,000 to $10,000 for that small all-in-one multi-rotor. Yes, you can buy an actual drone just itself for usually around $2,000 or something now for some of the cheaper ones, but all in, you really should expect 5 to 10 if you want to actually get everything you need. The next one is going to be your large more modular multi-rotors, like again using DJI. DJI, for those that aren't familiar, is overwhelmingly the market leader. I'll talk more about them specifically a little bit later, but your large multi-rotors are usually about 3 feet in diameter. They're a lot more, they weigh more, 10 to 30 pounds, something like that. They cost about $40,000 all in. Those prices have actually been coming down a little bit. Now they start usually around 30 grand all in or something like that. And they can actually still get you about 1/10 of a foot accuracy. The reason they're different, they have modular payloads. These ones can carry LiDAR. Your small all-in-one multi-rotors, it should be noted, cannot carry LiDAR, nor will they ever be able to carry LiDAR at that size, at least not for many years until LiDAR technology changes a lot. Small all-in-one multi-rotors, no serviceability, no modularity, but they're very, very good. Large multi-rotors, much harder to use, bigger, more expensive, but you can change out your payloads. You can have a LiDAR-specific payload. You can have a photogrammetry payload. There are a lot of manufacturers that will put their own custom payload on a custom drone or something like that. That makes it a very complex system. It makes it heavier, but it's able to have a lot of that modularity. These are becoming more popular as people start buying LiDAR more often. And then there are fixed wings, or VTOLs, which stands for vertical takeoff and landing. These are drones like the EB was popular for a long time. The Wingtra is a little bit more popular. And these ones fly like an airplane, usually about 3 or 4 feet in wingspan. They weigh a little less. They run around $25,000 or more, and they go up from there. They've really fallen out of favor the last couple of years. A few years ago, fixed wings were extremely popular. These have fallen out of favor because multi-rotors have gotten so much more just simple operationally. You can just push a button, multi-rotors take off from anywhere. Fixed wings are hard. You kind of need to toss them to take them off for the EB, and then they kind of crash land and bits break on them. They also, by flying like a plane, they can't just hover in place. They actually have to fly. If they're moving faster, they're moving higher. They're great for covering lots of land, but like if you're doing a couple hundred acres of topo, they're pretty good. But what people have started realizing is that these multi-rotors are actually totally capable of doing multi-hundred-acre sites themselves. As their battery life has gotten better, they can cover more land. They're so much easier to just swap out batteries. So multi-rotors have really been eating up the fixed wings and market share. We're seeing people are still successful with them. So if you own a fixed wing, that's great. I mean, they do collect perfectly acceptable data, but they've just fallen out of favor as far as new drone purchases go, certainly. And one of the big next questions, so now we've gone over the airframe types, is sensor types. LiDAR or photogrammetry is a really, really big question right now. Here we have 2 sensors that fit. These are both DJI sensors that fit on the M300. That's going to be their L1 LiDAR sensor and P1 photogrammetry sensor. But before I start talking about the specific sensors, I want to talk about generally the concepts of, do you buy a photogrammetry drone or a LiDAR drone? And I mentioned this a little bit earlier, that photogrammetry still is the most popular, the most common, the most boring, routine, repeatable workflow. LiDAR is getting all the attention because it's the new thing. That drone photogrammetry for survey has been around now for 5 years or something, and LiDAR is only just starting to get more accessible, more cost effective. So which one do you want? Well, LiDAR has much better cover in vegetation. This is just a picture of a cross section of a slope with some vegetation on it. And you can see this real color one that goes over the top of the trees is going to be the photogrammetric based point cloud. And this false color one is going to be the LiDAR point cloud. So you can see in vegetation, LiDAR systems are much better at doing topo in vegetation. However, photogrammetry, the old boring one, is typically going to be a faster workflow, faster processing overall. It's an easier workflow with much smaller drones, those small all-in-ones versus a large modular LiDAR system. Photogrammetry actually remains more accurate on hardscape, and this is one that not everyone believes me, but I promise you for most systems we've done the tests that photogrammetry is more accurate on hardscape, and that's for a couple of reasons. One, people say, oh, I've used my terrestrial LiDAR and it's so much better at getting curves. And that's absolutely true. Terrestrial LiDAR is on the ground. It is not moving as much. It has a distance from the laser scanner to the actual target of maybe 20 to 50 to 80 feet or something like that, whereas the drone is vibrating, moving constantly, kicking around with a lower power source, less powerful power source at 200 to 300 feet in the air. So generally speaking, trying to compare aerial LiDAR to terrestrial LiDAR, that's really a false comparison. They're very, very different systems. Even though it's the same laser, it's the same point cloud format, the way they actually work is pretty different. So once you count in all of those factors, on hardscape, photogrammetry, when done properly, is absolutely more accurate still. The other thing is for features that might not appear in 3D that are very visible in a photo. Take a manhole, for example. If you look at a picture on an ortho photo, a manhole or maybe a utility valve or utility access panel or anything like that is extremely obvious to see and say, yep, there's my manhole. And if you've ever tried to pick out a manhole out of a point cloud, it is way, way, way more challenging. Especially, then you have to worry about like, oh, well, okay, it's an uncolorized point cloud, so maybe I filter by intensity, and maybe you can see it if the intensity of the return on the surface of the manhole was different from the rest of the asphalt. Maybe you can't. It's a mess, and you can do it, but it is easier and faster and typically more accurate with photogrammetry. So yeah, a lot of this is I do kind of pull back a little bit from what is the current hottest trend in surveying out there to say, what is the most common thing? It's still photogrammetry. It's a much more mature processing workflow right now. And so photogrammetry is often better. But LiDAR does work better in vegetation, like I said. Some vegetated areas, just for some examples. If you need to do topo on a site like this, you got an awful lot of trees, yeah, LiDAR might be for you. Or if it's, pretty rural, a lot of trees, again, need topo, yep, that makes sense. You probably want LiDAR. If your sites look more like this, that is not enough tree cover to justify a LiDAR drone. If I were getting to pick which drone got flown with that, or let's say if I were the pilot and said, I'm going to do a survey of that, what drone am I going to bring in my truck? I'm going to be bringing a small all-in-one multi-rotor for a site like that. It is so much less intrusive. It's easier just across the board. The data processing is easier. And LiDAR will provide absolutely negligible benefit for vegetation on that order of things. Or likewise, if you're doing stockpiles, earthworks, you live in the desert, any of those things, no, you don't need LiDAR at all. You really don't want LiDAR. It's just a pain in the butt, and it makes processing longer. So all of the reasons you should not use LiDAR, and this is, I'll be honest, it's meant to scare a couple of people out of LiDAR, because we see a lot of people that buy LiDAR when they don't need it. And then again, they don't fly their drone as much, because LiDAR drones are harder to fly. You probably don't need LiDAR, and if you do, you probably know that you really need LiDAR because you're doing that much topo in vegetated areas. Topo in vegetated areas, that is the reason you want aerial LiDAR. If you don't often do topo underneath vegetation, then you don't want LiDAR, because it is much more expensive, they're bulky and hard to fly, the accuracy is not quite as good as photogrammetry, processing takes time, and I say must be run in parallel with photogrammetry. That's not necessarily true. We recommend it because of all of the things that I said before. Looking for things like manholes or 2D planimetric features, all of that is typically much easier in photogrammetry. But so we recommend running LiDAR parallel with photogrammetry. I mentioned in there, LiDAR drones are bulky and hard to fly. That's a fascinating thing when it just comes to human nature that really impacts how often people use a drone. And we talk to our clients and see people that have, a Phantom 4 RTK and then an M300 with a LiDAR sensor. And if you have both of those and you've ever seen a survey guy walk up and say, which drone do I want to pick? The entire Phantom case is like the size of a suitcase. And it's everything you need and you throw it in the truck. And the M300 is this monster that takes two people to lift into a truck. And then it also has a battery case by itself that weighs like 60 pounds or something like that. And then typically a separate case for the LiDAR unit itself. And then you probably, there's just so much more junk that it's incredible how often people are like, I don't have space in my trunk, or in my truck, I'm going to get that one. And they bring the other drone. Those sorts of things, it's remarkable how much that really impacts this type of drone program when you get to the level that I really love, which is that boring, repeatable level, right? Once you get beyond the excitement that it's a flying robot with lasers strapped to it, once you get past that initial excitement, the size of the suitcase matters a lot. Yeah, question. No, great question. So most LiDAR systems today have a LiDAR sensor and a photogrammetry capable camera on board as well. That includes the DJI-L1 sensor or most of the other popular sensors. They have both of them as well. When I say running in parallel, it's a single flight. Sometimes you have to adjust the overlap so that it can do both at the same time, but it's still a single flight. The parallel is on the processing side, that you would do the LiDAR point cloud and your photogrammetry point cloud, and then effectively extract data from both of those. That's what I say with parallel. So it's not two different drones. It's not even two different flights. Same drone, single flight. However, a lot of people turn off the camera sometimes when they fly a LiDAR drone, which we think that's not a great idea. You got both of them on there. You know, even if you have to increase your overlap a little bit to get photogrammetry to work, we think that's a very, very good idea for a robust field operations workflow. The next thing when I'm talking about drone components that I want to talk about is your GNSS workflow and your GPS processing. This is what, if you're actually a GNSS, GPS, RTK, PPK nut, this is what I'm going to be giving another talk about in about 45 minutes or so, whenever the next talk is. Actually, does anyone have, how long do I have on this one? And it goes till 10? Okay, awesome. I forgot what time it ends. It goes till 10, and I want to make sure I didn't miss anything. Oh no, I know there's a clock. Oh, there's that. I have a clock on my wrist and on my computer. I literally didn't even know what time. I forgot what time it ended, but thank you. I appreciate it. All right, so this is what I'm giving my next talk about. It's going to be the GPS processing workflow for all of this. So the way that this works, this really actually matters for the accuracy that you get on your drone, because there are so many different ways you can process GPS. In the same way that there are so many different ways that you can process GPS in a job site without a drone, right? Just whether you have two base stations, you're getting an Opus solution on one, you're using network RTK, you're in a PPK ring, all of that good stuff. Because the way that it typically works, you start with a drone that has GPS. It needs to be corrected against something. The best way that we usually recommend is correcting it against a local base station. And this local base station will then have a really short baseline distance, extreme corrections to the drone so that you get very high precision. But then how do you correct your local base station? Is it set up over a known point? You're going to do an Opus solution. Is that based on ground control points or network RTK? Well, that means you need to connect it to a permanent base station somewhere, whether it's network RTK or some other known point or something like that, to get your true level of global accuracy. But the other option out there that a lot of, again, hardware manufacturers will pitch that I personally, from the data side, do not like, is having the drone talk directly to a permanent base station via some sort of VRS system or network RTK that you can connect a cell phone to a hotspot and connect it to a network solution or to a core station. Or you can even do this just totally in post-processing by running PPK of your drone against the actual drone as the rover stream against a core's base station or something like that. I really don't like that workflow, though, just because of the nature of how drones are flying, how quickly they're flying, how much they're moving. Having a long baseline distance has a very different meaning with regular surveying and with drone surveying. Regular survey, you can use network RTK because you can take a 5, 10, 20-second observation, and if it says, I didn't get the right data, it's not good, you can take a 30-second observation. Drone doesn't work that way. The drone is moving around at 30 feet per second. It is moving constantly. Longer baseline distances, even more like a few miles, really, really start to rapidly diminish the accuracy of drone-based RTK relative to a local base station. So if that's the type of stuff where I talk a lot about that tomorrow. Yeah, question? It's a great question. We haven't done super robust testing on that specific question yet. I can tell you 1 to 2 miles is definitely in the good zone. You're absolutely fine. 20 plus miles, you're in trouble. I don't know exactly where that cutoff is in the 2 to 20 miles. We haven't done really robust testing on that yet. But usually when you're doing, the VRS or post-processing against cores, 20 miles, there are a lot of sites are not going to be within 20 miles. Is 10 good enough? I don't know. And this is where, come to my next talk, because there are other considerations as well when it comes to actual network-based solutions of why I really recommend a local base station for drone operations, at least. Having some sort of local base, whether it's a DJI local base, Trimble, Leica, anything, even they're super operationally simple. They don't need to be set up over a known point. You can literally just like stab the pole in the ground, turn it on, have it stream corrections, and that's a massive improvement for those drones. But I'll talk a lot about that in the next talk. So one of the questions, do you need RTK on your drone? So this is pretty simple. We recommend that any newly purchased drone for surveying should be RTK enabled. If you have an old drone that's not RTK enabled, you probably don't need to upgrade if it's working for you. But RTK on drones, airborne RTK, has really, really proven out its reliability. It's much more reliable. You don't need to set as many control points. If you do have any sort of ground error for any issue, like a control point blew away or a car parked over it from the time you set it to the time that you flew your site. If you don't have RTK, that site's basically trash. You need to refly it, or you need to shoot some more targets or something like that. If you have RTK, it provides a lot of workflow resilience. Especially on larger sites, RTK can save a huge amount of times and really improve their final accuracy. So when it comes to RTK and drones, we basically recommend if you're buying a new drone for surveying today, then you want RTK on it. That's, yeah. Question? Great question. Larger sites, RTK starts to really be beneficial. Anything north of about 20 acres would be larger sites. If you're doing 100 acres, then you need RTK pretty much to do a drone survey on anything 100 acres or plus. If you're only doing 5 acres, the benefit's a little bit smaller or something like that. That again, it's not going to be an accuracy thing when you're doing a 5-acre site. It's more of a resilience. Like I said, if you lose a control point or something, RTK can really keep that precision very, very tight. And as I'm talking about RTK, we'll talk about this in the next one as well. Do I still need ground control with RTK? I've got this local base station and really, really great GPS data. And I will say good RTK or PPK is technologically, it is capable of producing survey-grade accuracy without ground control. However, in the real world, no control, especially for land surveyors, is not good enough. You need to have some control, or if we're splitting hairs, you need to have ground-based check shots that don't necessarily need to be used as control, but you do need ground data. That is because ground control or checkpoints, ground data would probably be the better term, it is required to properly calibrate your camera. RTK gets you where the drone is, and if you don't have a lab-calibrated camera, there can be some variances in the lens just caused by humidity and temperature change and things like that. You might need it to localize your project if you aren't working in absolute pure NAT83. And having the ability to detect errors. All of this is really, really critical from a surveyor standpoint. So is it technically possible to do, what some may be calling direct georeferencing, where you can have a perfectly referenced point cloud without any ground control? Technologically, yes. In terms of real-world operations, I cannot discourage that strongly enough. As a surveyor, you really, really, really ought to have ground data in order to validate your project. And part of that is because human error remains very, very common in the more complex workflows, right? And if you work at a survey company, you've seen human error before because that happens all the time. You set your rod height wrong on the ground or whatever. You put in the wrong data. 2 surveyors surveyed a site and localized over slightly different points and it didn't quite work properly. That stuff happens. Having ground data is really, really important, even with RTK, even though RTK is technologically capable of doing it. Another question about drone hardware, and this is where I'm getting more into the whole drone system, right? Not the actual drone itself, is what base station do I use? Well, you could use no base station at all, which is going to be when you use ground control points only for all of your accuracy. You could also use the DJI DRTK2. If you have a Phantom 4 Pro or Phantom 4 RTK or a Mavic 3 RTK or a M300 drone, you may have seen this base station as well. It's DJI's branded GPS base station that comes on a real cheap aluminum tripod thing, but is actually, and it only does one thing. It streams corrections to the drone. It is not going to replace a Trimble or Leica or anything like that, and it streams corrections to the drone. And it's actually very, very good at that one job. So we actually, I know this is a controversial statement almost. We actually really like the DJI DRTK2 station because it's so stupid simple. It's literally you stab it into the ground like a spear. You don't need to, it doesn't need to be set up perfectly. We've done some tests. It doesn't even need to be perfectly level because the little leveling bubbles on it are also cheap and kind of crappy. But you just set it up. It streams RTK corrections to the drone, and you can handle everything else in post. And it does that job super simply, reliably, and easily. Again, I am not saying that this is going to replace your survey grade for any ground-based surveying, but it's very, very good at what it does, and it's so stupid simple. It literally has 3 buttons. You push on in the middle one, the lights turn green, and you're good. That's what the setup is on that one. You can absolutely use your third-party base station to stream corrections to a drone as well, whether it is Trimble or Leica or Carlson or all of those. That is a much more complex workflow. Accuracy-wise, it's pretty much the same. It's totally great. Technologically, it's very, very good, but it's a more complex workflow because you have to set in your TCP IP protocol numbers to actually get it to broadcast via NTRIP in the right format. You need to make sure that you have the right age of drone base station that can broadcast in the right frequency. These drones actually use a lot of GPS data. I mean, they run at 5 hertz for those that are interested. So that means 5 GPS observations per second. So your base station actually has to be capable of recording and broadcasting at least 5 hertz to get good data. So that's one of those ones a lot of surveyors say, well, I already have a base station, so I really don't want to buy the DJI one as well. And you can do that. But that goes back to the workflow I was saying before. If you're comfortable with a lot of technological troubleshooting, managing the wireless and network connectivity issues that are very common, managing your specific data collector, if you want to do that, then sure, you can get away with one of those local base stations, and it will work absolutely fine. The DJI one is just way simpler, which is part of why we like it. With the downside being, yeah, you kind of have to have an extra piece of equipment. Let's start over here. Yeah, it's radio based. So the way that it actually works, the base station connects to the controller via a radio link, and then the controller rebroadcasts that to the drone via a radio link. Typically, when you are working with a third-party base station, the base station would create its own Wi-Fi network to broadcast the NTRIP connection, to broadcast the correction stream via NTRIP protocol to the controller, which then rebroadcasts it via Wi-Fi. If all of that makes sense to you, then maybe you want to use your third-party base station. If that doesn't make sense to you, then you really ought to use the DJI base station because it just kind of works. Which is this is the type of thing that why we don't often recommend using the third-party base stations, because if you don't know how to set your base station to broadcast its own Wi-Fi network and stream via NTRIP protocol to your controller, and then have your controller linked to that Wi-Fi and type in the right IP address, that's the type of troubleshooting and just kind of knowledge and skill cap that you can't do with the intern. The DJI base station, you can train a guy, yeah, push it on, and if the light turns green, hit fly. That's there you go. On the DJI base station, I want to say it's about $2,000, a little less. So it's certainly not on par with any of your good Trimble gear, but it's non-trivial. I can get actual prices for you. I just don't have them off the top of my head, but that's important. Yep. Yeah. Logging rates are. Yep. So this might be a duh statement, but it's important. Drones fly fast. They fly at about 30 feet per second if you're flying at 400 feet or so, slower if you're flying lower. 30 feet per second. And they record GPS 5 times per second. That's a rate of 5 hertz. And even at 5 times per second, which is really, really high by surveying standards, as I'm sure you know, that means that between every 0.2 second interval, the drone is moving 6 feet. and it needs to interpolate that, because when it's taking photos, if it's in between, it might actually be 3 feet away from the nearest single instantaneous GPS observation. And you compare that, and when you're doing PPK2, ideally, you still want your post-processing, your base, to be at 5 hertz. There is no public base station that does 5 hertz, at least on like the Cores network or anything like that. I'm not sure about, Trimble's or VRS networks or anything that those even record it for. Usually they run at anywhere from 1 second frequency to even 30-second frequency. Now, if you're doing an 8-hour observation to do an Opus solution, then you want something at 30 seconds, because otherwise you're gathering a huge amount of data. And this creates another one of those big challenges, right? If you have your existing base station and you set it up for an 8-hour observation, if you're going to be flying the drone and using it for PPK, then you need to set it to 5 hertz. And 5 hertz for 8 hours is like 80 gigabytes. It'll overflow the memory card, cause problems there. And again, it's very challenging. And these are some of the technical issues where, once again, why we recommend this is because this has one job, which is to stream corrections to the drone at 5 hertz and do it properly. And this is much more flexible. So that's, again, where those kind of trade-offs come, because you do have to limit the amount of data that you use. Again, I'll talk a lot more about this. I want to get to some of the more drone-specific stuff right now. So let's talk more about PPK in the next talk. Like I said, permanent base stations only. We don't recommend this. We think a local base, because of the short baseline distances and the reliability of the workflow, we much, much prefer having a local base. Here's just kind of a summary of all of the different processing options. So no RTK at all, using only ground control points. Super affordable, super simple, but most field time in a lot of GCPs. You can run everything just in post-processing, which gets you high accuracy, fewer GCPs, less field time, but it's pretty time consuming to do everything in post. Our favorite, RTK with a local base, again, DJI or third party, as well as RTK with NTRP, which is the internet protocol for streaming network corrections. We don't really like that. It requires cell connection, error-prone workflow, and typically those baseline distances cause problems. And so the next thing that I want to talk about is one of the more politically touchy ones, but I think I have to touch on it because this is actually really important to a lot of decisions for people buying drones, is where is your drone made? And as most people know, the majority of drones are made in China and owned by Chinese companies. People say, well, I don't really like that, and that's very reasonable. I wish there were more competition. There are definitely some Swiss drones and other manufactured drones out there that typically are going to be a lot more expensive, and American-made drones are most commonly known for the military drones as well. You can actually buy some of them. You can buy Lockheed Martin's multi-rotor. I just think it costs like $190,000 or something, and is actually a pain in the butt and not as good of a survey drone as a $6,000 Chinese one, which is this is a real challenge talking about where drones are made, because there is a lot of desire to have non-Chinese drones out there. And what I want to then talk about is, well, what do you actually need to do to get a non-Chinese drone, and why are you looking for it? If it's just is it because you actually have a client that maybe works for the Department of Defense, or you're working on a military site and they specifically say no DJI drones? Well, that's actually an interesting question. Are they saying no DJI drones? Or are they saying no DJI or no Chinese drones? Or no drones owned by made by Chinese companies? Or no drones with components made by Chinese companies and Chinese parts? There's a whole range of spectrum of what type of drone, where it's manufactured, and what you need. So I think it's really important to identify all of that stuff first, of what you actually want, because this whole idea of it's like, well, I want a non-Chinese drone too. And I really wish there was. I really want there to be an American manufacturer that is competing with DJI. But right now, there is no comparable like DJI, but non-Chinese version that comes without very significant trade-offs. And this part of this, one of the questions that you actually have to ask, which is kind of weird, is how non-Chinese is non-Chinese enough for your applications? DJI is the biggest company that everyone knows. It is a Chinese company. They are manufactured in China. They get the most political attention because they are the biggest. And then people say, oh, well, Autel, they're a great company. They're actually still a Chinese company, and their drones are still manufactured in China. But there are some governments that, for political reasons, have said, no DJI drones allowed on our site. But an Autel drone will actually work, even though it's definitely still a Chinese drone made in China. They have some drones that I think they do some really misleading marketing where they're like, this one was made in the USA. And if you read the fine print, every single part was made in China, shipped in a box into a facility in Washington, and it was assembled in the state of Washington. But it is still a Chinese company and a Chinese drone, but it's not DJI. So that actually satisfies some things. When you go to like Rock Robotics, which is one that has a lot of marketing for their LiDAR systems, and they're an American company, it's typically still a lot of Chinese-made parts attached to a Chinese airframe. Even when you get to a lot of the assembled in the USA drones like FreeFly, if you actually look into it, most of the parts, many of the parts are still made in China. So depending on what your client's actual requirements are, if you are working for the military, even these like FreeFly assembled in the United States, you're already talking orders of magnitude higher budget than a lot of your Chinese or DJI ones, and they still won't comply with many of the military requirements until you get to your Lockheed Martin style drones. And the reason I bring this up is to say that it's not a simple answer, right? Like, it's not just there's DJI and then, I don't want to buy a DJI because I don't want to buy a Chinese drone, so I'm buying this instead. It's not that simple, right? The world is so frustratingly and gloriously interconnected at the same time that it's really, really hard to buy anything that isn't at least in part made in China. And so you have to say, how non-Chinese is Chinese enough? And I've got some recommendations towards the end for what are some of the non-Chinese. But again, you really almost need to look at what's your application, who's actually putting in the requirements, and what requirements are they? Is it just non-DJI, or are no Chinese drones allowed, and what specifications do you have to meet? Because at the end of the day, DJI is unquestionably the market leader in drones. Any non-DJI drone will have significant trade-offs relative to the DJI ones. They will be potentially, well, they are almost always much harder to use. They're more complex. DJI has done a great job with just a simple user interface. Oftentimes, they have fewer features. They don't have the same collision avoidance sensors or different modularity in terms of their sensors or terrain awareness in terms of their flight control or things like that. Usually, they are much more expensive than DJI drones, and sometimes they have worse accuracy too. That last one is not always the case. A lot of the more bespoke drones, they are going to be much more expensive and harder to use, but they can get better accuracy than DJI drones. But it's really worth at least acknowledging the fact that right now, DJI is the market leader and they make generally the best drones. And if you step away, there are going to be trade-offs. If you're comfortable with those trade-offs, that's perfectly fine. That's not my job entirely to tell you which trade-offs make sense. There just absolutely are trade-offs there. All right. So now let's actually talk about hardware with our last little, with our last 20, 25 minutes or so. And just kind of the drone ecosystem of what hardware is out there, what drones are out there. This is actually one of the parts where I want to hear from you of what other drones you have questions about once I get a little bit into kind of the framework. I've been talking about DJI a lot, and that's because generally the market right now is DJI drones and everyone else drones. And this is what I was already mentioning here. DJI drones have a pretty darn simple workflow. They are relatively cheap with your kind of all-in-one ones starting in the $5,000 to $10,000 range, and your modular multi-rotors, your LiDAR drones starting in the $30,000, $35,000 ones. Easy to use and good, though admittedly not always the best accuracy, particularly in the LiDAR sense of things. Downsides, they are Chinese made. They don't have the best hardware support, so we would recommend getting them from a dealer that actually provides decent hardware support. And it's not true bleeding edge technology. It's going to be a lot more reliable, a little bit more proven. DJI was not the first drone to stick a dual band RTK GNSS antenna on a drone. They were the first ones to make it easy. The everyone else drones, specialized to your needs, made or usually often assembled in the United States out of Chinese parts, sometimes with American-made companies, sometimes not. Generally better hardware support and more cutting-edge technology, with the downsides being they have that much more complex field workflow. Getting your Wi-Fi set up properly, making sure that your radio signals and your antennas are oriented the right way. They're more expensive and usually require specialized training. To get into the actual drones themselves, DJI's survey-grade drones. These are These three right up here are by far the most common survey grade drones right now that are made from DJI. The first one is the Phantom 4 RTK. That has been the absolute workhorse of land surveyors for the last 3 or 4 years or so. And you will see that it is no longer available. they haven't officially discontinued it. They are kind of quietly discontinuing it and winding it down, as it is being replaced by the Mavic 3 Enterprise RTK. This is the new workhorse. We have tested it. This is absolutely, honestly, it's very, very comparable to the Phantom 4 RTK. If you've flown the Phantom 4 RTK and liked it, you will fly the Mavic 3 RTK and like it too. It's not revolutionary, but it's the next step up. It's smaller, it's quieter, it flies a little bit longer, it can cover a little bit more area. The camera is ever so slightly better calibrated, but it's, for all practical purposes, it is exactly the same. This, over the next 3 to 5 years, will be, absolutely, in my professional estimation, this is going to be the most common survey grade drone over the next 3 to 5 years. And partly because, like I was saying, it's boring. It's quiet. You can fly this anywhere, and once it goes up to 200 feet, it is invisible and nobody can hear it. It's easy. It comes, even with all of its batteries, it comes in a thing the size of like a lunchbox. The thing is tiny. And people think, oh, it's tiny. Does that mean it can fly in wind or that it's not actually a good drone? No, we've tested the heck out of this thing. I really, really like that as far as DJI drones go. And we've been swearing by the Phantom 4 RTK for photogrammetry drones, just as the workhorse drone for the longest time. This is going to be the new workhorse drone that we typically recommend. It's really easy to use. And then DJI's next step up is the M300. This is their large multi-rotor with either an L1, their LiDAR sensor, or P1, which is their photogrammetry sensor. Let's talk about those sensors for a bit, and this is where I'll probably want to hear your feedback too, is specifically on the L1. This one is also a very controversial sensor. I've heard very different things from different surveyors. It is a LiDAR sensor, a Livox Avia sensor, for those of you that love the underlying hardware, with a 20 megapixel photogrammetry global shutter camera. That camera that is on there is effectively the same camera as is on a Phantom 4 RTK or a Mavic 3 Enterprise RTK. Absolutely photogrammetrically capable, very good survey capable camera. In general, it can get about 0.2 of a foot vertical accuracy when using the LiDAR sensor, or about 1/10 of a foot vertical accuracy when using the photogrammetry sensor. With fully integrated RTK and PPK, it is affordable, $35,000. That's not the sensor. The sensor is only about, they've lowered their price. I want to say it's like $8,000 or something for the sensor. That $35,000 is for the entire thing. That's including the drone, the batteries, the DJI base station, and all the other junk you need with it. And it's very easy to use with a reliable workflow. Now, the reason it's controversial is because it is not as powerful of a LiDAR sensor as many of the other kind of more custom grade drones that are out there. It does have a little bit more spread in terms of the actual LiDAR cloud that is out there. And other surveyors will say, well, I want to get this more powerful LiDAR. I don't want to get the L1. It's not actually the best LiDAR sensor out there, which is absolutely true. I'm not going to try and argue against that. But typically, 0.2 vertical accuracy, if you're using LiDAR is for going through vegetation. If you're doing topo underneath trees and vegetation, 0.2 vertical accuracy is usually good enough. And then you use the photogrammetry for when you're doing things like your paint striping or stuff for your Alta survey, or for your hardscape, you're going to use photogrammetry. And so for us, this is one of those sensors where it is absolutely good enough. And I'm curious, does anyone have any experience with the L1 or thoughts or what they've heard from other sensors about the L1 or any other LiDAR sensors from drones out there? Nothing. Yeah, in the back. Okay, cool. Thank you. And I always like hearing that feedback because I know, like I said, I have heard a lot of people say they don't like the L1 because the LiDAR is not as good. But from what I've seen and experienced, it is often good enough, especially at a price and reliability point, because to go to a lot of these other systems, you're taking huge steps up in terms of overall system complexity as well as post-processing. post-processing is so underrated in terms of how it should be considered in the drone buying process. Part of why, again, we like DJI, they're just simpler. So this is our favorite LiDAR sensor. And I had another question that I was talking with someone earlier today. So how much of your data is of your LiDAR data actually comes from the L1 sensor? And I can tell you it's about 60% of the data that we process comes from the DJI L1. But interestingly, it is not 60% of our customers who fly drones use the L1. But people who use the L1 use it more often, which is just one of those interesting things from our perspective. People that have the L1 will fly it every week, a couple times a week, or maybe every month. And people that have some of these more bespoke LiDAR systems, because they're more complex, they're harder to use, will use them maybe every 1 month, maybe every 2 months, not as frequently just on every single job, because the L1's a little bit easier. It's an interesting observation that I've found that, that's anecdotal. I don't have a full survey of all people that have ever used a drone LiDAR system, but we see people with the L1 using it more often. Yeah. Yes, I'm pretty sure it is. If you want to look it up, it's the Livox Avia is the actual sensor inside. They're going to have the full detailed tech specs on the sensor itself. I'm pretty sure it's a solid state sensor. Yes. Yeah. Not with speed of flight. Yes, with altitude. If you fly very high, call it 400 feet, which is about the highest that a drone can fly, you'll get a little bit worse than this. If you fly it at 100 feet, which we would call very, very low for a drone flight, you will get a little bit better than this. This is kind of your approximation. I should have the little squiggly line in there for approximate accuracy for most drone flights. Most drone flights are in the 200, 250 foot kind of above ground range. Speed doesn't make a huge difference in accuracy. Altitude does make a big difference in accuracy. All right, moving on to the next common DJI sensor, which is the DJI P1, their photogrammetry sensor. This is specifically a photogrammetry sensor. It has a big 45 megapixel image sensor. You can typically get better than 1/10 of a foot vertical accuracy, fully integrated RTK PPK. Same approximate price as the L1 all in, or again, if you call it like 40 grand, you can buy a P1 and an L1 sensor, and those both can go on the same drone. Very reliable workflow, but what we've found with the P1 sensor is that it is much heavier and harder to use because you're going from this small 2-pound drone to a big 30-pound drone, with only marginally improved results. The P1 is a really mixed bag. It's a little bit hamstrung by the camera lens that they put on there. Without getting too much into the detail, they only have a 35 millimeter camera lens. I wish they had a 24 millimeter one with a wider field of view. That would be much better for survey purposes. But overall, it's completely capable, but it just gathers so much data. It's hard and heavy to use. It's kind of a pain in the butt just all around for really negligibly improved data accuracy over the Mavic 3. And this is one where I kind of talk about that. Beware the sales guys. They're like, well, the Mavic 3 is your Mavic 3 Enterprise. That's your entry level photogrammetry drone. If you're a real pro, you buy this photogrammetry drone because it's a bigger camera, better camera, more megapixels, blah, blah, blah. And I see, like, honestly, no, this one I have a hard time recommending it just because it's so much more of a pain to use for really negligibly improved results. If you're looking for a photogrammetry drone, buy the Mavic 3 Enterprise RTK. If you're looking for a LiDAR drone, the M300 with the L1. This is kind of an awkward middle child that doesn't get as much love, and I think it really deserves it that much. Talking a little bit more about then DJI's non-survey drones. DJI does have a whole bunch of non-survey capable drones out there. That is most of the Mavic series, with the exception of the Mavic 3 Enterprise RTK. I should also take a step back and say that I want to murder whoever's in charge of product naming at DJI. They make it so damn confusing. The M300 is actually newer and better than the M600. The Mavic 3 is not a good drone. The Mavic 3E RTK is the Phantom 4 Pro V2 can work for surveying. The Phantom 4 Pro V2 Plus cannot be used for surveying. It's ridiculous to get a hold of all of these. And I lose track of them, all of them as well. They also have a whole series of other drones that are honestly super cool, just not great survey drones. The Air, the Mini, the Avata, the FPV, things like that, all have different use cases, ranging from a pocket drone that you use to chase your dog around and take pictures of. I have one of those, and it's fantastic, and I love taking it for pictures. There's an FPV drone for racing. They have all kinds of drones, but generally speaking, not survey-grade drones. The only kind of in-between exception is there's a Mavic 2 Pro out there that people bought for a while when, especially when supply chains were really, really tight, and they didn't want to buy the Phantom 4 RTK, but the non-RTK version was discontinued. The Mavic 2 is capable of survey and photogrammetry. It's pretty good for small sites, but it's hamstrung by what's called a linear rolling shutter. It's a special type of shutter in the camera that introduces distortion in the processing side of things. It can be corrected for with software, but not perfectly, and that software correction becomes very, very challenging for large sites. Again, in this case, when I say large sites, I typically mean about above 20 acres. I would really be hesitant to use a Mavic 2 for anything above. This isn't for new drones, this is even for existing drones if you currently have one. No RTK, very challenging for larger sites, but if you have one, it is definitely still capable of survey on smaller sites because this is just a common DJI. Before I get into non-DJI drones, any other questions about DJI stuff that's out there? Yeah. I don't like it. I apologize for that if you have one. It's a cinematography drone. It's totally capable for cinematography, especially with some of their X5, X7 cameras that have all of these very interesting f-stops of light and dynamic lighting systems, but they are non-survey grade cameras. They have, if I were filming a car chase, then that is the drone that I would probably want. If I were performing a survey, I don't like it. It has a lot of distortion. It doesn't have good RTK or PPK. I don't know, I'm not sure if they're even still selling it, but it's just not quite the right drone for surveying. An Inspired, what, 3 or something? I look forward to testing the data out for it, but we haven't had our hands on it yet. And that's where, you know, my perspective is what's available now and what have I tested. And I can tell you the instant that comes out, we will be one of the first people in the country to have one of those drones on hand. And we will run it through the ringer for testing. And you can shoot us an email. You can shoot me an email and say, hey, Inspire 3's out. What do you think? Where's the data set? We actually even publish sample data sets and reviews and all of those things. So I'll be interested to see how that works out. If they can have a RTK enabled Inspire 3 that you can slap that P1 photogrammetry sensor on, I'd be pretty intrigued. That sounds like that could be a very, very capable survey grade drone. As it stands, the Inspire 1 and Inspire 2, I don't like them. Not good. Cinematography. Yeah. Yeah, because what that can do that's really cool, the way that its legs suck up and the camera's down there, it can have dual controls so that the camera operator and the drone operator can be separate controls, and the camera can have a full 360-degree view underneath while the pilot navigates it through city streets, again, like filming a car chase. It's really friggin' cool. It's just not a survey drone. 8 minutes? All right. Sorry, I'll keep going. If you got more questions, you can ask me. I want to cover the everyone else drones out here as well, because that's DJI. They're the market leader, but there are a lot of everyone else drones out there, ranging from Autel, which they attempt. There are some even in the exhibit hall there. The specifically this one, the Autel Evo 2 RTK. Positives, it's not made by DJI. That's cool because for companies that literally, there are some, especially like municipalities that are specifically no DJI drones. That's what's listed. Doesn't say no Chinese drones, it's no DJI, so this would fit that bill. But it is still made in China by a Chinese company, and it still has a linear rolling shutter, which hurts accuracy. It is not as good as the Mavic 3 Enterprise RTK. There are trade-offs, 100%. Like, is it capable of survey? Yes. Is it as good as a Mavic 3? No, and it's still made in China. If you need a non-Chinese drone, and this is non-Chinese enough for you, this is a perfectly capable, completely competent mapping drone. Another drone out here is the Skydio 2 Plus. This is another really interesting in that kind of small all-in-one multi-rotor. It's American-made, but it has its own challenge. It's really not designed for survey. No RTK, rolling shutter, relatively low-resolution camera. This was one that was designed really for public safety in mind, and it's great for those applications. Unfortunately, just not a good survey drone, really struggles with anything more than a few acres, even though this one actually is made in the United States, which is kind of a pain. Wingtra, the Wingtra 1 is a really intriguing drone. This one takes off vertically, then tilts, flies like an airplane. Swiss made, very good data quality. Again, the fixed wings have just kind of fallen out of favor recently because they're not as flexible in terms of their field operation use. This one's been designed for very large projects. If you are frequently doing sites in excess of 50 acres, it's worth considering. But it is going to be more difficult to use than a DJI, and this is quite a bit more expensive. Depending on all of their options, and they have a lot of different options and who you talk to and very opaque pricing, but typically on the order of about 50 grand or so, and then you'll need more pilot training, more specialized, that sort of thing. Rock Robotics is another one that has very good online marketing. They are their own LiDAR sensor and camera. I mean, it's like a Sony camera that they integrate and everything put into a payload. That is still typically on an M300 platform. We don't love this one as much. It can go on other platforms other than M300. It's one of those, another hard ones that people are like, I don't want to buy DJI, so I buy this. But it's a much more complex workflow that just has a lot of human error introduced to it. It's not that the data can't be good quality; it absolutely can. But it's just a complex workflow, so we don't really love that. So just to kind of wrap things up with the last few minutes here, with the conclusion and a couple of our recommendations, actually, which you can probably guess what some of them are going to be. First off, what's the best drone for pictures, video, and fun? Honestly, the DJI Mini 3. I say this because a lot of people say, it's like, well, what if I want to just take pictures? This is what you want. It's $650 for bunches of extra batteries, like propeller guards, cameras, all of that. That way you can fly it around with your kids and your dog. It's tiny. It's so small, it weighs less than half a pound, so it doesn't even need to be registered with the FAA. This is a cool one if you actually want a drone just for pictures and fun flying around the house. No, you cannot survey with it. Is that going to be your question? Yes. Mm-hmm. Yeah, it's a super simple process. It's like $5 to register a drone. But yes, yeah, any other drone that I've even discussed here has to be registered with the FAA. This one is so small that it just doesn't. It's a very, very. Yep. Yeah, here's surprise, surprise after everything I said. I hope you're not surprised by this. Best overall for land surveyors, we like the Mavic 3 Enterprise RTK. For all of the reason that I mentioned before, this is going to be the new, call it Ford F-150, right? You're boring. You're going to see it on most job sites, by far the most common. You can teach a kid how to fly this thing. It's so darn simple. It's super reliable. We love it. If this were made by an American company, then that would be the answer. Buy this drone and don't worry about anything else. That really is how good and simple this workflow is. Best LiDAR drone for surveyors is going to be this M300. That's not as strong of a recommendation because the M300 is harder to use. If you are doing sites that need LiDAR, this is the one that you want. Best of the bespoke manufacturers. This one, I don't have any universal recommendation, but if you did want to go out of the DJI ecosystem and get something else, I have a hard time recommending anyone in particular because they all have these trade-offs. But if I had to pick one, GeoQ is a great company. They have some really smart people. their TrueView LiDAR system produces very high quality data. It's still a pain in the butt. It's a more complex workflow, both in terms of field and processing and all of that. And oftentimes this is a GeoQ sensor on a DJI airframe, so it still often is DJI stuff. But if I had to pick it, there you go. And the best of the non-Chinese ones, the fixed wings actually are pretty capable. If you did have to do something that was a non-Chinese made drone, non-Chinese company, go for either Wingtra or SenseFly. SenseFly, they got bought. They're Ag Eagle now or something like that. But the EB fixed wing and the Wingtra fixed wing, those will actually work. I still should point out these ones are not going to be Department of Defense compliance. So if you are working on, like if you had to do a survey of a nuclear reactor or something, these would still not be compliant enough with the highest tiers, but they're probably there. But just to summarize again, our favorite drone overall is the Mavic 3 Enterprise RTK. And with that, we are out of time. So if you have any questions before everyone leaves, first of all, we recorded this on video. We have the decks. We're happy to share the slides with anyone. You can shoot me just shoot me an email if you want the slides. If you have any other questions. A couple of last things before I go is I've got a booth out there later today, giving another talk about RTK and PPK stuff in half an hour. But yeah, with that, just shoot me an email. And thank you all so much for your time and attention. And we'll finish the raffle thing now.